evening and happy Monday. Last time on Wednesday, we looked at review techniques for integrals involving trigonometric functions. Right? Now we're going to look at tricks up. There are three substitutions that we use. First substitution is if the integrand involves a function that has square root of a squared minus x squared. We make this substitution. X is a sine of theta. Dx obviously a cosine theta d theta, and with some algebraic manipulation, which is in the video, the square root itself becomes a cosine. Second type of substitution is if we have the square root of a squared plus x squared. Here we use substitution, x is a tangent theta. That would make dx a secant squared theta. Again, with some algebraic manipulations, the square root becomes a secant. Finally, if we have the square root of x squared minus a squared, make the substitution x is a secant. Dx derivative is secant tangent. And the square root function becomes a tangent. So there's a reason why I derived all of this in the video. It's so that I don't have to redo all that algebra for every single problem. Which is what a lot of textbooks do. They just give you what the x should be, and then in every problem they go through all that algebra, which is a waste of time. You do it once, and you're good. All right, so the general methodology is first you identify which substitution you're going to use, make the substitution, simplify, and then you have an integrand involving trigonometric functions, and then we use the techniques that we've already reviewed. That will typically give you an antiderivative with trig functions, or inverse trig functions. You then have to back substitute, get it back into x. Which can be tricky if you're not comfortable with trig. So which of the three forms do we have?
First.
Sure?
Yeah, because it's 3 squared minus 4x squared.
Okay, but that doesn't say bx squared. It says x squared. Technically, we don't have any of the forms yet.
Okay.
So we have to get it to be like that. Right. Notice each one is, coefficient of x squared is 1. That's what we want.
Okay.
2 ways you can do that. First way is a u sub. You get that u be 2x. Then you have u squared, which fits that first one. Problem is, that's not a 2x down there, which you have to do some manipulation. Second way, and the way that I typically go, factor out 4. Once I'm the square root. What's square root of 4?
2.
What do you get when you factor 4 out of 9?
Probably 9 over 2. 9 over 4.
9 over 4.
Yeah.
Now we have that first.
Right, the 9/4 is my perfect square.
So what's x going to be? So if a squared is 9/4, what's a?
X.
Yeah, square root of 9/4 is what?
9 halves.
Not 9 halves.
3 halves.
3 halves.
Yeah.
There's your x. Dx would then be 3 halves, cosine theta would be theta. And there is what the square root is going to become. 3 halves cosine. So plug everything in. 2 times the antiderivative. That's square root 3/2 cosine theta over x 3/2 sine of theta times dx. Three-halves cosine theta d theta. So that's making the substitution. Simplify it.
Cancel those things out. Wouldn't that be the cotangent? Yeah.
Not 2. Right, factoring out 3/2. That's a problem. How would you do that?
How do we substitute to get the 2 and then the stuff on the bottom? Where it says 2, then 3 cosine theta. How did we get there?
Here?
The 1 over. Yeah.
So the 2 is from factoring out the square root of 4.
Okay.
This is the square root, right?
Yeah.
That becomes 3/2 cosine theta.
Uh-huh.
X is 3/2 sine of theta.
Oh, and then, yeah.
And then dx becomes that.
Okay, what happens to 9/4 though?
You just need that to determine what the a is, what your coefficient is.
Oh, okay. Oh, we just put it for like the x tangent.
We didn't use tangent. That is if it's a squared plus x squared.
So what did we just plug that into?
We plug these 3 values into here.
Okay.
Right, so the square root of 9/4 minus x squared becomes 3/2 cosine. So just replace it. X's become this, and the dx becomes this.
Oh, I see.
So it's just plugging these in to the original integrand.
Okay, yeah, I see it.
And then simplify from there.
Okay.
So making this cotangent doesn't help. Leave it like this.
Oh, yeah.
Cosine squared. Or my sine squared, right? But that denominator is a monomial. So I can split this into 2 fractions. 1 over sine minus sine squared over sine.
And then sine squared over sine is probably just going to be sine.
And what's 1 over sine?
1 over sine is secant, yeah. Or cosecant, I mean.
There's our integrand.
Okay.
Cosecant is a known antiderivative. Negative, just log. Natural log of cosecant minus cotangent is the antiderivative of cosecant. What is the antiderivative of sine?
Negative cosine.
So there's that antiderivative. But our independent variable is supposed to be x, not theta. So we have to,
Do we just rewrite all that and replace theta with x?
it's not x, because we didn't say x equals theta. We said x is 3/2 sine of theta, so it's not that simple. Two ways to approach it. Algebraically, or using right triangle trigonometry. Let's start with algebra. Cosecant. 1 over sine. We know what sine is. 2x over 3. So cosecant has to be 3 over 2x. Cotangent is cosine over sine. Cosine is 2/3 the square root. Sine is 2/3 of x. So the 2/3 are going to wind up canceling out. So there's cotangent. And we know what cosine is. 2/3 of that square root. Times 3 is going to be 2. Not plus. And we can clean that up a little bit. We need to multiply by 2 over 2, right? If I pull that 2, it's the square root of 9 minus 4x squared, isn't it? So I could write it like that. Or laws of logarithms. And that 2 there, I can just rewrite this as that log minus 3 log of 2. And 3 log of 2 is a constant, isn't it? So it gets absorbed into the constant integration. This is probably how textbooks would have the answer, by absorbing all the constants together. So we'd say this is our antiderivative. That was the only step of calculus, by the way. That was the only calculus we actually did. Everything else was algebra. Calculus is easy. Algebra's hard. 95% of calculus is algebra. All right, let me show you right triangle. What do we say theta is? The inverse sine of 2x over 3, right? So that means sine of that angle is just 2x over 3. What is sine in right triangle trigonometry? Well, that's true. But if you're given the right triangle, what is sine of that angle?
Opposite over hypotenuse.
Opposite over hypotenuse. 2x, 3, and then this missing side. Square root of 9 minus 4x squared. Cosecant. Hypotenuse over opposite. Cotangent. Adjacent over opposite. Cosine adjacent over hypotenuse. And then, of course, here is case 1. Which is exactly what we got using algebra. So your choice. You can either use right triangle trigonometry or try and use algebra. For this substitution, sine and cosine, algebra is fairly simple because you can write every trig function in terms of sines and cosines. When you start getting into tangents, secants, what is cosine or what is sine in terms of tangent and secant? Secant times tangent. We'd have to know that. If you try to figure that out, it might be easier just to do right triangle trigonometry, depending on how long it takes you to figure out that sine is secant times tangent. Remember correctly. Next problem has the same square root. So now it's the denominator. So using the same argument, I better write 2 dx's. Oh dear. We'll do a factor out of 1/2. And it's going to be the exact same substitution. It's the same square root. Dx x and then the square root. Three halves over 3 halves. Cosine over cosine. We're going to be left with the 3 halves in the denominator that can be factored out as a 2/3. Be left with 1/3. D theta over sine theta. But 1 over sine is cosecant. What's that antiderivative?
possibly negative cotangent?
That'd be cosecant squared.
We just said, is it maybe negative cosecant over cotangent, or cosecant over cotangent?
We just did it
Oh,
in the last problem.
oh,
That's the value of cosecant theta minus cotangent theta.
Log of the absolute value of cosecant minus cotangent. All right. Now I have to do back substitution. We said what cosecant is. 3 over 2x, right? And we said cotangent square root of, I'm going to use the right triangle form. Square root of 9 minus 4x squared over 2x. Which can write that way. Thank you. Hold on, as long as you can. First thing we want to do, get that to be just x squared. So you can factor out a square root of 9. So factoring a 9 out of 16. Ninths. Why did I do square root? Because I thought it was 3 halves. So it's not a 3 that's being factored out. Right? We're not factoring out 9, we're factoring out a 9 to the 3 halves. 27. Root 9 is 3, 3 cubed, 27. So 9 to the 3 halves is 27. All over x to the 6th. What is x going to be?
16 over 9 minus x squared.
So which of the three forms is it?
Number one.
So what is A?
4/3.
There's substitution. And then with all the algebra, this is our full substitution. All right, so we get 27 times the antiderivative. What does that numerator become?
We're taking the antiderivative of 60 over 9 minus x squared.
I'm just doing substitution.
Okay. So it would be 4/3 cosine theta. That would be
Just that?
raised to the 3/2 power.
Not
third,
third.
third power.
Okay.
The third power,
What is-
because this is the 1/2 power.
Oh, okay.
So let's just say 4/3 cubed times cosine cubed for right now. What's the denominator become?
4/3 sine theta raised to should be the 6th power.
The what?
So raised to some power.
Which power?
Is it the 6th?
Just the 6.
Okay.
And then dx is just 4/3 cosine theta. And here's why I left it as 4/3 cubed for right now. That's 4/3 to the 4th over 4/3 to the 6th, which is what?
1/4 squared.
What's 4/3 squared?
16 over 9.
Which is going to come out as a 9 over 16, so it's 1 over that, right?
Right.
9 times 27.
243, I think.
Yeah, it's 3 to the 5th. Right. 3 to the 5th, 243. Oops. Get over 16. Oh, joy. Cosine to the 4th over sine to the 6th.
Well, because all those 4/3 cancel back to back.
Already dealt with the, yeah, already dealt with 4/3. That's where the 243 over 16 came from.
So it's a cosine third, then another cosine.
Yes.
Fourth, okay.
to decide, how do you want to write this?
So we write, say, cosine over cosine to the fourth over sine to the fourth sine half, or sine squared, I mean. So that it can be,
Where's that sine squared?
yes, it's still in the denominator.
Yeah, it'll still be in the denominator, right?
Yeah.
How does that simplify?
So it would be tangent sine squared. No, cotangent sine squared.
Cotangent,
Cosine over sine.
right? But is it just one?
Well, if it's cosine to the fourth over sine to the fourth, it'll be cotangent to the fourth.
But then not sine squared. 1 over sine squared.
Which is secant squared.
Not secant,
Cosecant squared.
cosecant. That's one way to do it, and that's how I'm going to do it. You could also write cosine squared as 1 minus sine squared. Then this becomes 1 minus sine squared squared. Expand that out, and then divide each term by sine to the 6th like we did before. You get what? Cosecant to the 6th minus 2 cosecant to the 4th plus cosecant squared. Have fun. That's quite a bit of work. This is easier. How do we do that?
What step are we going back to?
Huh?
What step are we going back to?
Now we're doing this. How would you be better with that?
Oh. I wonder if 243 actually divides by 16.
It doesn't.
It does, okay.
243 is strictly a power of 3, 16 is strictly a power of 4. 3 or 4 does not simplify.
Okay. So we'll just leave it like that, I guess. And then,
Actually, technically 16 is strictly a power of 2, not 4. 4 is a power of 2. Alright, so if you break it down to pure prime factorizations, they have no common primes. So they can't have any common factors.
so that's the lowest terms. Alright. Oh, because are we taking the derivative of that then?
Anti.
Taking the antiderivative, okay. Probably need some identities.
What's the derivative of cotangent?
Just had it. Derivative of cotangent is negative cosecant squared.
Isn't that negative du then?
I suppose it would be.
And that would be u to the 4th.
Yeah.
This is u sub.
Yeah, huge substitution.
So we're going to have negative 243 over 16 times, now what is the antiderivative of u to the 4th? but u is cotangent.
Oh, and then the rest of that just goes away.
Well, it's not really going away because this is negative du.
Oh, and then
So we get negative u to the fourth du.
oh, and then
Right? That's what change of variable does.
and then okay, u for du is that.
U to the fifth over 5, but we said u was cotangent.
Okay.
Right? So it's like the inverse chain rule.
All right.
Actually, it is the inverse chain rule, right? It's the antiderivative equivalent of chain rule. 16 times 5.
80.
And that won't simplify because 5 is a prime, and there's no 5s in the numerator. Cotangent to the fifth. We need to write that in terms of x.
Let's see. X is 4/3 sine. So
What is sine? Sine of theta is
4/3.
3x over 4.
Yeah.
What's the missing length? Cotangent is 1 over tangent. Tangent is opposite over adjacent. Cotangent is then adjacent over opposite. Square root
Radical 16.
16 minus 9x squared over 3x, but that whole thing is raised to the fifth power because it's cotangent to the fifth. What's 3 to the fifth?
6.
It's 243.
Oh, interesting.
So they're going to drop out. You get negative 16 minus 9x squared to the 5 halves over 80x to the fifth plus your constant. There's the antiderivative.
So that's the final answer, and it can be left like that. Okay.
Or you could switch it and write c minus that if you don't like having negatives out front.
Okay.
I don't, but I don't like having arbitrary constants as the very first thing I write. And that is a bigger pet peeve of mine than the negatives out front, so I leave it in this form.
Okay.
Oh, yes. does this fit one of the three forms?
Can you try and factor out an X or something?
That's not going to be too helpful.
'Cause it
You
kinda-
could technically factor out an x to the 1/2.
I mean, could 2x be a? No. So it kind of doesn't, it looks like.
Yeah, that doesn't fit any of these three.
Yeah.
That's a problem.
Yeah.
But we're clever. It actually does fit one of these three.
Just have to rewrite something or change.
This is a trig sub problem.
Okay.
There's this lovely technique in algebra when dealing with quadratics. What is it?
I want to discriminate or something like
That's not really a technique.
that.
Is
No,
it?
yeah.
It's called completing the square. We're going to complete the square on what's in the denominator. First, I'm going to write it with a positive x squared. So I'll just factor out a negative. How do we complete the square, members? You think your algebra teacher's very savvy. We did this in pre-calculus, by the way. I did it in the derivation of the quadratic formula.
Down.
I used completing the square.
I'm sure there's a formula, but
It was what, +1 -1? Or no?
How'd you get it? Because you're right, but how'd you get it?
Like in the middle, it has to be like 2ab. So, like, I don't know.
oh, is that like a, it's like sort of like a difference of squares or something?
Take half of b and square it. Half of 2 is 1, squared is 1.
Okay.
So we want that to be +1. But you're not allowed to add 1. You can only add 0. So 0 is 1 minus 1. So there it is, +1 minus 1.
Okay.
Remember, that only works if the coefficient of x squared is 1. If it's not, you have to use a different technique. Generally, I just factor it out, the coefficient 1, and then half of b squared. whole point of doing that those first three terms form a perfect square binomial. It's x minus 1 quantity squared. Then just to shoot that negative back through. Almost there. Now make a u substitution. Let u be x minus 1. What's du? So it's the derivative of x minus 1.
1.
It's just 1. So du is dx.
Yeah.
So the denominator becomes the square root of 1 minus u squared. You get the du in the numerator. Uh-oh. What is x squared then? So if u is x minus 1, what is x?
X. U is x minus 1, x is u plus 1.
So the denominator becomes u plus 1 from x squared. Oh boy, I'm going to have to expand that at some point. Question is, do I want to do it now? Yeah, it's probably less hideous to do now than later.
Alright.
What form is that?
So now it looks like that looks like the first one.
It is. So this is a sign substitution. That's how I usually refer to them. Sign substitution, tangent substitution, or secant substitution. What is A?
One.
It's just 1. Best case, your A is 1. There's our substitutions. Now make those substitutions.
Can the cosines cancel or no?
They can.
Okay.
Yeah, that's what I'm going to have to do, isn't it? There is another way you can proceed from here. Right, so you could just stop there and then negate that antiderivative. It's perfectly valid.
Or
There is another thing you can do.
maybe if there's a monomial, you'll divide each term by cosine.
Well, that cancels. Those cosines canceled.
Oh, nothing you can do after you cancel.
Yes.
Okay. Maybe factor it. It looks It's not like a quadratic.
Well, it is quadratic.
Yeah.
I'm trying to find the antiderivative. So you could just go, what's the antiderivative of sine squared? What's the antiderivative of sine? What's the antiderivative of 1? That's perfectly valid.
You're right.
I'm probably going to do 3 antiderivatives. I can do it in 2. No, I can't have mine. I was thinking of something else. Darn. That actually really sucks. I'm thinking of my hyperbolics. No, so I'm going to have to do this. Do all 3. Well, these 2 are fine, right? What is the antiderivative of 1?
X.
Well, it's not x in this case, but
Theta.
it's just theta, right?
Yeah.
Antiderivative of sine.
I don't think it's negative cosine.
It's negative cosine. And what I'm going to do is I'm going to write that for right now, because that's the only one that we have left to evaluate. Oh, wait a minute. We did that Wednesday evening. How did we do it?
Probably would have to use some form of substitution.
Remember that reduction identity?
Yeah.
Which makes this antiderivative half of theta minus a quarter sine of 2 theta.
We can kind of combine some like.
Theta plus half theta.
I believe that would be 3 halves theta.
Seconds for that. But when we go to back substitute, that sine of 2 theta is a problem.
Oh yeah, because it's not.
Remember?
Angle.
Remember what I was saying? It has to be of a single angle.
Yeah.
So how can we rewrite 1/4 sine of 2 theta?
It's an identity double angle, I think.
It is a double angle.
Do sine theta to sine theta.
So that's your sine of 2 theta. Yes. Times a quarter.
Oh,
1/2 sine cosine. And plus a constant. Now we can go back substitution. Start with theta. What's theta?
Would it be sine?
Well, u is what? Sine of theta?
Yeah.
So what's theta?
inverse trig?
Which one?
Yeah, sine.
It's the inverse sine of u.
Okay.
What is cosine?
Of cosine of theta? Yeah.
Square root of 1 minus u squared, right?
Yep.
What is sine? Just u, right?
Yep.
And so we get minus a half u times square root of 1 minus u squared plus a constant. Are we done?
Trying to see if we can combine these like terms. I mean, 2 and 1 half u both have to be. We have to do something to get rid of the inverse trig. Is this a matter of simplifying it a little bit?
Not in the sense that you're thinking of.
Okay.
So we have to get the u's to be x's.
We have to go back to x.
Oh, yeah.
Our independent variable is x, not u.
Right.
Well, what did we say u was?
Sine. Something about.
In terms of x.
Oh.
Otherwise, we're going to go right back to here.
Yeah.
X minus 1.
Now, square root of 1 minus u squared. If you follow this back, 1 minus u squared is not 2x minus x squared.
Yeah.
Not plus.
Should we maybe distribute the 2 blue or?
You need the parentheses then. You combine like terms. That's square root of 2x minus x squared is a like term.
Right.
Minus, I'm factoring on minus, so you get 2 minus a half,
Yeah.
3 over 2, minus x over 2. 3 minus x over 2, all minus.
Okay.
Could technically just write everything over 2. Could technically do this. one has a 1/2. It doesn't matter.
Would it be wrong if you put, like, if you just put the whole thing and you put 2C?
I don't even need to do that. I could just do that. 2C is still a constant, isn't it?
Yeah.
That would also be correct.
Okay, so they're both kind of.
But you don't typically see that in calculus.
Okay.
You will see that in differential equations. But in calculus, you typically, you just keep the C separate.
Okay.
So there's their antiderivative. Again, I just want to point out, this was the only step involved. You can have like 10 pages of work and one line is calculus. The rest is like algebra. Time flies. It's already 7:15. I only did 4 problems. Hour and 15 minutes for 4 problems. It's actually not too bad. You get a problem that takes you 2 to 3 hours. And then usually by the end you forgot what the original question was. You forgot what you were doing.
So you have to write everything down.
Okay. Well, this one looks fun. Does this fit one of these 3?
Yes, it is. Right now, no.
Okay.
But
Nope.
no.
So what are we going to have to do?
But first, though, was to try and factor the bottom.
If only.
Yeah. Maybe we factor something out and then factor the bottom.
We'll factor.
Can we make like out of 27 9 somehow? Or no?
27 into 9, that's not going to work. Well, I mean, you theoretically could, right? It'd be what?
We would have a formula.
It would be 9 plus 18.
Then we do 2x minus 3.
Yeah, you got to complete the square here. So you could factor out a 4 first to make that x squared a coefficient of 1. I think what I'm going to try and do is not do that. Do this. 4x squared. So a is 4. So I want to write 24 as 2 times 4 times something.
2 times 4 is 8. That missing number is 3.
Yes. Oh, this would be really fun. So it's going to be minus, I'm going to write it that way for now, 3 times 8x. And then plus 27, so 3 halves. Only this was nice. That 3 is our B.
Oh, are we gonna try like use a quadratic formula?
We have to have it and square it.
Okay.
Oh, wait. I'm sorry. A is not 4. A is 2.
Because of that power?
Because that is going to be, when you do the binomial squared, it's ax all squared.
Oh, yeah.
Oh.
So, okay.
So I want my A to be 2. So it's going to be something times 4 is 24, and that's 6. And that's where the mine's going to come in. Half of 6 is 3, squared is 9. So plus 9, but then you need plus 18, right? Because 27 is 9 plus 18. That's what we're going to have. Let u be 2x minus 3. What's du?
Du is 2.
It would be 2 dx. So we're going to need a 1/2. Now we get u squared plus 18 to the 3 halves. du. What substitution do we use?
From over there, let's see. This looks like the second, the tangent one.
It's tangent. What is a?
U. 1.
Sadly, it's not 1.
Oh, because of the exponent, you mean?
Number addition is commutative.
Is it that?
So a squared plus x squared and x squared plus a squared are the same. This is of the form x squared plus a squared. So what's a?
Oh, x squared plus a squared. I guess a is radical 18.
square root of 18, which is 3 root 2.
Okay.
There's our substitutions. du 3 root 2 secant squared theta d theta. U squared plus 18 to the 3 halves.
Let me see.
So it's going to be a secant cubed, right? What is 3 cubed?
27.
What is root 2 cubed?
It's 2 root 2.
2 root 2, 27 times 2?
54.
3 root 2 all cubed would be 54 root 2.
Is that all? No addition, subtraction.
That's it. Oh, I forgot to add that 3 root 2 in the numerator. That's going to make this easier. So the root 2's drop out. What's 54 divided by 3? It would be 1 over 2 times 18, 1 over 36.
Do those secants actually cancel out?
You're left with what? D theta over secant, right?
Yeah.
Which is what? Just cosine. Oh, look how sexy that is. What's the antiderivative of cosine?
Sine.
(136) sine of theta plus a constant.
That looks pretty simplified.
What is sine of theta in terms of u?
Would it be 3 root 2 tan?
You want it just in terms of u, you don't want cosine.
Okay.
So 2 ways. You can look at the triangle or algebra. Sine, remember, is secant tangent. Tangent of theta.
3 root 2.
U over 3 root 2, right?
Yep.
Then this would be the square root of u squared plus 18.
Yep.
Sine.
U over the hypotenuse.
But now we need u in terms of x.
I guess we did did like 2 substitutions, huh?
Yeah.
Yeah.
We did change the variable twice. We first changed x into u and then u into theta. U is what? 2x minus 3? And square root of u squared plus 18 is going to wind up being the square root of 4x squared minus 24x plus 27. There's the antiderivative. Students typically hate this technique. I like trig. So I actually like this. Any questions on trig sub?
I guess I have to do it a little bit more.
Well, the hardest part's going to be the trig. It shouldn't be the calculus.
Yes, keeping track of all like the substitutions and things like that,
And then your trig identities.
and the trig identities. Yeah. Alright, so that's enough for that.
First quiz. Pass it back. So it's 4 questions. 2 are worth 10 points. 2 are worth 5. Covers integration by parts, trig sub, as well as the techniques for trig integration. Make sure you do your work in pencil or black ink. Make sure you write legibly. And that I can read it and understand it. So if you're going to use pen, I don't want a lot of crossouts and arrows, because that makes it difficult for me to read and grade. I don't want to spend a lot of time trying to understand your problem. So if you're going to use pen, do it on scratchboard first, and then write your final solution. Same thing for pencil, I don't want crossouts. And make sure that when it's erased, it is actually completely erased. If I can't read it, I'm not going to grade it. That's my rule. I'm an old man. I have bad eyesight, so don't write really tiny either. I'm not reaching for a magnifying glass. You may write on the back of the page, you may write on separate scrap paper as well. Just make sure that you clearly indicate in the problem that it's continuing onto the back or onto scratch paper. For the scratch paper, make sure your name's on every sheet and then attach it at the very end. Also on the scratch paper, clearly label what problem it's a continuation of. So you're allowed to use your notes, your textbook, the handouts that are up on Teams, the review of pre-calculus, the table of derivatives, and any, well, I don't think CAS is going to help you in this quiz. But you can use CAS. You just can't use it to actually evaluate the integral. We haven't gotten to that yet. Right, obviously you're not allowed to discuss it with anyone other than me. Can't look up your solution on Google, Chegg, whatever out there. I don't think ChatGPT is good enough to do calculus yet. I don't think any AI is good enough to do calculus yet, at least not the free ones. So I think I'm safe there, but it is up there, you're not allowed to use AI. So what will we do at the start of class Wednesday? If there are complications with my daughter's surgery and I can't make it into class, then it will be due Monday. It's not up there. I gotta put that up there. Most importantly, as always, have fun. Questions on the quiz? All right, so don't forget, first 7 math assignments are due the 21st this week, or after this class you can do the 3rd assignment. As of right now, there are only 2 people who are even registered for my math class. You may want to get on that. You don't want to wait till the last minute to try and do all 7 assignments. It won't end well for you. That's a guarantee. It will not end well. Man with a lot of alcohol trying to get through it if you're drinking each. And if you're not, a man with a lot of alcohol that I don't want to know anything about. And again, the first quiz is due to start a class on Wednesday. Keep your eyes peeled on Teams. If there is a problem and I can't make it, I will message you on Teams. As well as how we're going to meet, we're going to do virtually. If I'm just going to do something else. I'm not going to know that until Wednesday. Hoping everything goes smoothly. I don't know. Good luck. See you Wednesday evening.